Talked about the first derivative. Now let's have a look at the second derivative. And all the second derivative is differentiated a second time. So the notations that we use for the second derivative, y double dash or double prime, some people call it prime, f double dash x. Now d2 dx2. When people sometimes see this for the first time, they mistakenly think that we're squaring the derivative, and that's not what that's saying. So d2 dx2, and then the function that we're doing the calculus on means find the second derivative, differentiate it twice. And probably the most common way we see it is something like that, d2y dx2. Okay, so here's our, well, it's a quadratic. Let's differentiate it a couple of times. So differentiate it once, we'll get 6x plus 1. Differentiate it a second time, we'll get 6. I mean, it's no big challenge. If you know how to differentiate once, then you know how to differentiate twice. You just got to do it a second time. Square root of x squared plus 3. Well, before I differentiate that one, of course, I'm going to have to put it into index form so we can use the chain rule. All right, so let's differentiate it first time. Bring down the power, so half comes to the front. Lower the power, so half becomes minus half. And then we put the boot in. Diff the inside. So differentiate the inside, we get 2x. Tidy that up because a half times 2x is, of course, x. Now, I'm not going to worry about putting that back into the other form because I'm going to have to differentiate again. So it's probably more convenient to leave this in index form to find the second derivative. This is where we've got to be careful because now I'm going to have to use a product rule because I now have a function of x times another function of x. So write down the first, x. Diff the second. Oh, hang on, there's that x squared plus 3 to the minus a half. Okay, going to have to use the chain rule again. Bring down the power, minus a half. Lower the power, minus 3 on 2. Diff the inside, 2x. Don't stop there. Common mistake, people stopping there because they think, well, I've done a lot of work. That must be it. Yeah. But no, we've still got to go plus, write down the second bit, x squared plus 3 to the power of minus half. And diff the first, we just get 1. So let's tidy that one up. We've got minus half times 2x, but then it's also times x, so we'll get minus x squared, and yeah, a mere mortal might leave it like that, but us super mathematicians, we notice, hang on, there's a common factor there, of x squared plus 3 to the power of minus 3 on 2. So let's factorise that out. Remember, when you're factorising, the lowest power is what you take out, so it's minus 3 on 2 is the lowest power. So I'll be left with minus x squared. And then sometimes people get a bit mucked up when we've got negative powers. Remember, factorizing is division. So if I divide x squared plus 3 to the minus half by x squared plus 3 to the minus 3 on 2, I would subtract the powers. So minus a half minus 3 on 2 becomes plus 1. So I'm just left with x squared plus 3 inside. And well, the minus x squared and the plus x squared cancel. And I've now put it into a much nicer looking format, putting it all back with surds. So 3 over, well, it's 3 over x squared plus 3 to the power of 3 on 2. 3 on 2, 1 and a half. So it's x squared plus 3 to the power of 1 times x squared plus 3 to the power of a half, which is the square root of x squared plus 3. And there it is in a beautiful looking format, our second derivative. Okay, that's all I really need to say about that. Let's have some fun.